In the previous clip, we've seen series that are that have a sum and series that are not converging. Here I will discuss a necessary condition for a series to converge. So this is a minimal requirement, a necessary requirement for a series to converge. Well, the statement is rather easy, so it's the following theorem. So suppose we have an underlying sequence an, and we look at the corresponding series Sn. Then we have as a necessary condition that the series can only converge if the sequence an has a limit 0. So what does it mean? In order to have to be able to speak of a sum of all elements in the sequence an, these elements must be smaller and smaller. They should have a limit 0. So what is the statement? So if Sn converges, then it should hold that the limit to infinity of an equals 0. Well, the proof is not so very hard. If so, let's do it right away. It's just basically 3 lines. So if Sn converges, right? Suppose it is convergent with a limiting sum s. Yeah, so we have a sum. Then what we have also is that the limit to infinity of Sn plus 1 is the same as the limit for n to infinity of Sn equals s, right? So if the sequence of partial sums is closing in on s, then also the sequence of partial sums where we take an additional element an plus 1 equals the same limit. Now let's consider the limit that we wanted to calculate or wanted to show that it should be 0. That's the limit for n to infinity of an. Well, this sum is just, or this limit is just the same as the limit for n to infinity of an plus 1, right? So just the same reasoning. If an closes in on some ultimate value, then an plus 1 does it as well, and these limits should be equal. Now an plus 1 is the difference between Sn plus 1 and Sn, right? So realize that the Sn plus 1 is the sequence of partial sums until the n plus 1th element, and the Sn is the partial sum where we take the first n elements, right? So Sn is part of Sn plus 1, and the difference between the two is the n plus 1th element, an. Okay, but now we use the limit rules, since now we have a difference of sequences which have the same limit. Yeah, it's s minus s, so it should be that the limit equals 0. Okay, so this is a very easy property, but there's a general warning that the converse to the theorem does not hold, right? So it's not an if and only if, right? So recall that here we have a sequence, the sequence 1 over n, which has a limit 0, right? But we've just seen in the last video that the limit for the partial sums is infinity, right? So we cannot say that a series is converging if and only if the underlying sequence has limit 0.